Okay, so logistic regression. What happened earlier when we were working with normal regression, normal with your linear regression? Here also moving numbers. Here also moving numbers means
Continuous.
continuous. So you have this, you have this, so you have all this data that comes up, and naturally you try to, and then this is an equation. So that algebra is the model. That's what happened here. But somehow, sometimes you will have for a certain range certain responses. So your data itself, for some reason, it will be here, here, and here. It means for so much change, I'm so sorry.
That should be continuous.
Classes.
Those are classes and one should be.
It is continuous.
Both are okay.
This is continuous. This is what is happening here. From here to here, it held this value. The moment it changes from here to here, this was standard. From here to here, this was. You can think of it like experience. This much experience of months, salary is around this. This much experience of months, salary is around this. Now the question is, how do you fit a graph for this? How do you tell what kind of setup will you take to ask your algorithm? Because you take this and try to fit. What is it that will suddenly change? Like till here, this value is like eventually what? It is again a function. It's going to be a function of y and x, no? Something of y is no longer mx plus c, but something else should happen to x now to give you y like this. Means what? X keeps changing, y will be of a certain level. Then suddenly x changes in range, y changes in shift. What is that function which gives you this feeling? You're understanding what? We are not going to recreate anything. We are not going to create anything by magic. Whatever is already there, we want to bring that and give it the flavor. So that is your exponential function. Sigma, no, sigmoid is, okay, can say that. Yeah. One by one plus e raised to minus x. So when you try to fit this function, when you say use this as the base and fit the y, you will. So this is how it happens. So imagine you're a teacher, you want to predict whether a student will pass or fail an exam based on the numbers of hours they study. I just made my experience in salary, but this is also sort of because now experience in salary has too many classes, but this one has only two classes. Pass or fail. So there will be in the data, the algorithm will observe that everybody who has studied less than 2 hours have failed. Everyone who has studied more than 2 hours have passed. Algorithm should see it. You are not observing. Algorithm should see it. If the algorithm sees it, the curve is set. Where you find that after that it should go 1. Otherwise it is 0. Till that, after that it is 1. So that shift where it is happening, algorithm will see it, right? So if you think like that, Goal here is to set a logistic regression to find a relation between number of hours studied and probability of passing the exam. To yeah. start, you start with some data points. Each data point represents a student. X-axis represents number of hours studied. The y-axis vertical represents number of what is the outcome, whether pass or fail. Unlike linear regression, which fits a straight line, logistic regression fits a S-shaped curve called a logistic function or a sigmoid function. This curve can map any real valued number into a value between 0 and 1 representing the probability. This is the takeaway. So, is there a curve which can map a real valued number into a value between 0 and 1? This itself has what is a real number then? Real valued number, what it is? Go and find out. In numbers itself, number theory itself, there are many different kinds of numbers. Real valued number into a value between 0 and 1 representing the probability. This function, which function does that? Logistic function. Who created all these logistic functions? Mathematicians. General functions, theory of functions. Lot of people whom, hundreds of mathematicians whom we will never know. That's what they did. So making predictions, it's very simple. To predict whether a student will pass or fail, logistic regression uses logistic function to output a probability between 0 and 1. For example, if probability is greater than 0.5, predict pass. If probability is less than 0.5, predict fail. Training the model is just fatafat, simple. Put x, y, and this time don't ask for linear, just ask for logistic and give the input, it will do it. What is happening inside? Regression model learns from the data by adjusting its parameters to minimize the difference between predicted probabilities and actual outcomes. Models learns from the data by adjusting its parameters to minimize the difference between predicted probabilities and actual probabilities. We'll understand. Visualizing the logistic curve. Here's how logistic curve might look with our data. The curve represents the probability of exam. Here is that curve. I even have the curve here. I didn't have it. Let's put it here. So what should go here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For 1 hour study, what happened? 0. For 2 hours study, 0. For 3 hours of study, 0. For 4 hours of study, so this function itself will be in such a way that if you give x between 1 and 3, it will result in output is 0. It will do something to x. The function does something to x in such a way that between 1 and 3, output is 0. The moment the 3 value increases, output suddenly becomes. So what can happen to a function which becomes like this? That is the tuning part. What manipulations will you do to that? So this curve, general form of the curve is this, but eventually the model ends up becoming some value added, some value taken. But how it learns is by first by small tuning, it will see whether it is coming to that value or not. But it actually knows, right? Prediction. It will predict. For one, if it will start predicting pass and it will check for the reality, it will say actual is fail. So I have to tune that parameter more until I get for 1, 2, and 3, it should get 0 only. After that, it will get right. So this is what. So we'll see. We'll in this example you'll see different. So how the model learns, you initialize the parameters, start with a random value for the parameters of the logistic function, compute prediction, update parameters, and check the predicted and actual.
And why is it exactly called as logistic?
No, I think it's actually a sigmoid curve as the general form is sigmoid only, but you'll call it. Many people will call it different. So because it's a logistic function, it's a logical. You can set up a logical based on a logic. It changes.
Okay.
So it has the capacity to weave itself into the hidden class logic or something. You can think like that. Okay, so let's. I think this is the one. Yeah, same problem, right? Importing the libraries as NP, your friend, matplotlib, pyplot as PLT to plot a learn dot linear model import logistic regression again. I actually, honestly speaking, I will not even remember which library gives you what. There are so many libraries now that we have lost track. Right in your in your companies, they would have bought a different package, some high-end package from another group. All you have to do is which algorithm. Then you have to go and check the documentation of if I want to use this library, how is it that I'm going to give my X and Y to this? And they'll say, no, 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 there you put it X here, Y here, but here you have to set it like this. Eventually, inside, same gradient descent will, right? So sklearn.model selection import train test split, for which you are going to do 80/20. Import accuracy score. We'll understand, we'll teach you what accuracy score is. So R studied np.array, you make it an array, outcomes np.array, blah, blah, blah. Then R's, so you're going to reshape this data. R studied dot reshape -1 to 1. Okay, so I can tell you, but I will put this as a assignment. You have to go and put this, okay, and ask ChatGPT why would anybody want to. Okay, it's already given here, but fine. But you guys figure it out. Okay, why it is important. Tell me that. Training the model is X train, X test, Y train, Y test, blah blah blah, X Y test, and randomly zero. Is there any doubt in this? We have done this before in cars data, right? Model logistic regression. Model dot fit train X train Y. Was it any difficult? Is it not? Making prediction. Y pred is equal to model dot predict X test. So accuracy score you will get how much accuracy you're getting. In this case, you're getting 100% accuracy. So when it got 0.2 to 80% was removed for training, 20% is for testing. So out of this, I think randomly it would have taken 2 out. Maybe if you just say, if you just think about it, 2 and 9 taken out. And when you take 2 and 9 out, for 2 it is 0, 9 it is 1. So after the model got built using 1, 3, 4, 5, 6, 7, 8, and 10, you kept 2 and 9 to test. Then you tested the model. So 2 actual was 0 and prediction was also 0. 9 actual is 1, prediction also was 1. So that's why your accuracy became 100%. But if you have a large amount of data, then you'll never know. And if you have too many changes, that also it will observe.
What is the accuracy we can expect for a good model?
No, for a classification model, there is no bias variance sort of thing here. Okay, I think even if you go till 99.9, will it work this percentage, decimal percentage? Yeah, will work. So go for 90, at least 98%. Somewhere, some misclassification.
On this testing and
On training, on testing data, on testing data.
training data, it will work anyway. It will work. So because we have done it, it will work. On testing data, same thing should work.
Yeah. The
So,
training data we don't even consider.
mm,
Training data's accuracy is just simple.
mm,
Just to do will do. But real test of the model is on testing data. So expect around that. If you can get till 98% classification, that is fine. 100% is possible. 100% is 100. Is it not possible in your phone now?
yes,
Can anybody else's faces open your?
no,
It's not possible, right? So
yes,
they have taken. So what has happened here? It's deep learning, image processed, and it is the ability of your camera to extract so many features of your face, which are so distinct that nowhere in the world can it overlap with somebody else's. So that is feature engineering. How do you engineer those features? How do you select those features? And we'll come to that. You guys are getting the idea of feature engineering?
yes.
Feature engineering.
Considering the features.
Feature selection, feature
Selection, features,
engineering. Feature selection and feature engineering are two different statements. We'll come to that later. Okay, understand. So visualizing the results, you have all this step-by-step visualization. I'll send you this code. You can run this. This is not at all. This is just a experimental code where we show at every epoch how this curve is getting formed. This nobody will ask you. This is a research thing we have just set up. I asked ChatGPT to write a code to show me exactly how this curve. This is for me. I did. Okay, I wanted to check how this curve is getting formed. So these are all beta and all these things are your gradient descent algorithm. Inside the gradient descent, how it calculates inside. Every, as I told you, all learning happens because of this gradient descent algorithm, where you have this. Remember this ulta u,
yeah, we know that. Very
actual and different actual, it is going to come down, right? So that is
global,
what is happening.
global,
Yes,
global
global minima.
minimum.
So that is what is happening. The betas are getting calculated, and slowly the curve is getting formed. And at every point, it is checking with the actual and the prediction. Here, it was a prediction now. It checked, didn't work. Again, change the parameter, the curve. Again, change the parameter. Again, change the parameter. Finally, it will stop because the actual and prediction is now same. So it will stop at that value. At this point, this curve's exact algebraic map will be given. Like how mx plus c is fine, one straight line. But not everything is as straight as it looks, right? M will take a different value, c will take a different value. Where it is starting from, but form is mx plus c. But here form is the sigmoid form, 1 by 1 plus e raised to minus x. But what value of x and how much of that scaling of the x and how much weight will go into that x, right? For each range. So that is getting structured here. So we can. So I'll send this, and I think here also I think iteration. This also we the gradient descent algorithm is also here. Learning rate 0.1, number of iterations 1000. You will not understand this now. I'll tell you why this was created. Okay. Now let me give you a very interesting insight. Logistic regression is actually a very important concept, and you will never use it directly. This one is actually used in for data science people a little beyond the scope, but fine, good to know, right? This is deep learning. This is the mother of all algorithms, right? Inside this, you have something called an activation function. Each neuron. This is a different way of seeing a problem. This is as if you're setting up the problem as if the brain is going to solve this. Where thousands of neurons that you can create will all come together to gamble on an answer. And each one inside this neuron, there's an activation. And that function of activation, one of the function is ReLU is commonly. In fact, ReLU, in fact, we like ReLU so much that our logos, Analogica's logos I is actually the ReLU formula. Okay, so What I'm trying to say is another reason why we teach logistic regression in this much depth, the learning rate and all that. See here, the learning rate 0.1 and taking the sigmoid. Now, this learning rate is here also. And how fast this deep learning algorithm tunes up to do this classification. Because your image processing is a deep learning algorithm. Because here the features are what? Pixels. Lots of pixels. And pixels arranged in multi-dimensional. Not one axis, not two axis. Many. Yeah, convolution, many dimensions. Right? So in that setup, you can't, you will have to give it all. So here what happens? Auto feature engineering is there. You don't set feature. Automatically it will create its own features. So that's why it is called a black box. Deep learning is called black box. Hidden layers, right? We'll never know what feature it has created, but it is working. It says I have understood it now. I'll not tell you how I know that he is Gagan, he is Anil. I will not tell you exactly. I also don't know, but I know now. Right? So there is another field of study where they go into the depths of what model it has created to understand what feature it extracted. So people have understood. After understanding that only, they have gained a lot of knowledge and LLMs have come. Okay, this is actually pixel problem when you're solving a pixel level. This one. So inside this also there
This
is.
is easy. Iris is easy or the face? Face.
I really don't know. Have the data. Which is easy? I don't have the data to say which one is easy.
Depends on what's there in the data.
It's how deep that picture is. Iris.
So because ice looks very similar.
No, inside the eye.
Inside the ice.
Inside the eye, there will be all these variations.
They have to dive in deep for that.
I really don't have that knowledge. Maybe we should. I'll find out. Because that's a nice thing because I don't know. I've never studied. Maybe people would like to know something like this. Difference between the complexity of an iris in terms of a image processing problem or just a facial features. So no, I'm saying I don't know, but find that and write an article. People would like to read it. Your data scientist perspective of how many features are there. Write that. I would like to read it.
Because that is what we see when we consider these things. We are putting a, I mean, security. We will check whether face is
Now,
easy.
why it may be simpler? Face may be complex. Eye may be simpler, but your face picture is available on internet. They can mimic it, but you will never put your iris picture on internet. No, at least that way, that iris is, I picture is safe. So if really someone wants to check if it is really you, they'll give you an iris detector and you have to go and show the eye. But nobody can take your picture, 10 different pictures and make a mask out of your picture. That can be done, right? They'll make a 3D mask and show it to the this one and it'll open. How will the machine know it's real or not? An artist, Madame Tussauds, if you give, we should check that, right? We should train, take Shah Rukh Khan's photo and show that picture. What if it opens? Then anybody can open your phone later. But iris, nobody will do. Probably. I'm just giving my
And
think
iPhones
about
would have
it.
detected the dead and alive person's fingerprint also. Even they don't have the fingerprint.
Sure.
That is also there.
So I'll share this. This has every possible depth of logistic regression, which you will not find on internet or geek for geeks or anywhere, because deliberately everything was put into this layer. At different levels, you will understand different. If you want to go to depth of gradient descent algorithm of how it is working, follow this iteration per. For every line, you follow this iteration 0.1 a learning rate 0.1 0.2 0.3 it will give so many times it will do, and that is what, see, for every iteration beta values are changing, and finally, and I have told that you go for 1,000 iterations, and finally, what is this beta value? Take this code, put it in ChatGPT, and understand what this beta value is of a gradient descent algorithm. Hmm? But then there's other video also beta values, so I'll send you, which we have created. Where is that? probably back propagation. We calculate. Hmm. So gradient descent to find optimal value of P3 or observed minus predicted keeps on getting. That's why this is not there in the your data science. This is too complex. Somebody who's taken deep learning, everything, every step will be explained. Okay, so that is how eventually the curve happens. This is how eventually the convergence happens. And this is just for a small data set. And what is happening here is okay, this is a good point to show also, because you see, I have just abstracted, I have just abstracted one input, one output, two layers. Here there are, we just saw here there are, you keep on adding many inputs, many output, keep on adding depending on how many classes you have or how many classes you expect, right? And you keep on it. I am only taking a small problem here and I'm showing what this changes are. But inside this, see this? Some function this is an exponential function. This is an activation. So we are, the whole problem is to what degree will this neural network or neural cell get activated. That activation function, one of the functions used for a simple problem is the exponential function, or that, sorry, the sigmoid function. Like that, there are many different um, activation functions. It looks different for different, so I think I have that. I have it here. Different shapes. These are this squiggles, these shapes are there, right? Activation functions is a softmax, and this one is ReLU. This basically what it is doing, it is just trying to give you condition logic. This one is slow moving, but this ReLU is more like until you hit zero,
It's constant.
it's zero only. For zero, it is zero. Above zero, it will increase. So just for sigmoid, a bent curve, you will never know what kind of problems will require what kind of activation functions, right? So basically, that is the choice. In deep learning, the whole idea is everything is already set. Your choice of learning rate, activation function, and feature engine. What features you give it to the machine. Actually, as you go more and more deeper and deeper, everything is already done. But just because everything is done, your interview isn't going to be easy. They still want people who know, who deserve that place, who's come through. Because person who's sitting there also have gone through everything, no? So he wants to only include his tribe into the team. So the check of the tribe is to check all this, and it's only the fair way to learn. So this is what is happening inside. So that's the reason why this logistic regression function looks a little deep, because it's also part of the deep learning intuition understanding. But you can have this. I'll share this with you. This is not there in on Discord. Ravi, making sense for us?
Yes, Vijay.
Just take some data, build this model, predict it. Everything is hand coded here for you. No doubt left. Hmm? But for you, as an assignment, what you will do, you will just take another data. Which data you will take? Can you tell
The
me?
cars, there was
Super, super,
a
super,
problem
Ravi.
where
Absolutely. That's the thing that I wanted. Spam.
for the
The problem will be different over there. I
cylinder,
have
number
not
of
taught
cylinder,
you
number of door.
TF-IDF. I have to convert it into term frequency, and then convert it into vector. Then it becomes a number. Otherwise, I have not taught you how text become number yet. Right? So we'll come there. But this one is much more simpler now. As Ravi said so nicely, very appreciative. Really, Ravi, your intuition is really getting better. I'm so happy to see that. Where's that cast data here? Here only, no? Now I
Wind
want you
turbine
to.
data, fail or pass or fail.
Which one?
Wind turbine.
Ah, yeah, yeah, that also is fine.
Yeah,
Yeah.
it was there pass or fail.
Yes, no, but I was just wanted to uh, see if you can build something that is only two pair or pass. That also you can do. But here, try to check this. Cylinder. Because there are many, you know, 6, 8, 4, and yeah, only three levels, no? Yeah. And now you take this and take the price. Just take these two values. Add logistic regression, same copy paste, make rename logistic regression until you have exported the data where you're getting it to this level. Where here, import. This is anyway hard coded. But here what is happening, I'm doing x train, y train, x comma y test plate. This x comma y can be here in this, the x comma y is like this. But you know how to get the x from the pandas, right? And y from the pandas. You already know it. So take that, understand why this reshaping is required. See if your data requires reshaping, correct? Then go and add it to this function. That's it. Model.fit, x train, y train. Your things are done. Make prediction. That's it. Visualizing the result, you can visualize. If you want to see the curve being formed for a 3-class problem, check. This is your R&D lab after this to check the inner curvature. Nobody is going to ask you for this. Who will ask you for this? If you are joining some PhD program. If you are joining a company where, if you're joining a team of Skykit Learn, correct? Nobody else will ask you for these kind of details. But that is good to know. I mean, the more you know, the more confident you will be. More questions you'll come up with. And the right questions will, of course, have brilliant answers. And yeah, that's your. So simple. Will you do it tomorrow and send it to me, or today only after this 10:18 anyways? So do it for 12 minutes, fatafat. See what happens. Let's see what happens. Ravi,
Yes, sir. Yes, Vijay.
you can. All of you can do different. You want to check leather. You want to check cruise or not. You want to check liters. Anything that you want. You can check. Later, I'll show you when the classification becomes more and more complex. When the classification becomes more complex, then you will appreciate the decision tree model, the knife based model. Because eventually I have to give you reason. I have to give you reason why I am teaching knife based. No, simply I can't do it for syllabus. Hey, I was supposed to teach you this algorithm. What is the connection? So now you feel the connection. Why the class K? The class identified, correct? In K means class identified. So your range identified. Now you want to make predictions. Now you bring in the Y. Use all those ranges and convert it into one hot encoding and convert it into not one hot, just range encoding and convert it into class. One is class now, one is metric now. Now you use the logistic regression. But logistic regression is a very simple thing. What if you have many classes inside and many ranges? What will you do then? 10 different variables all affecting certain class. What will you do then? Algorithms will keep increasing in complexity. Then you come decision trees, then you come knife based, then you come support vector machines. You start seeing the problem itself differently. A change in perspective. That's how I'll put that story together, right? So eventually, at one point of time, you should be able to give 1 hour explanation of total. When this happens, this happens, this happens. When this happens, this changes, this happens, right? Once it is done, then you're fine. That's when you fine, Prithvi. But for today, I need the report on this one cluster. In fact, this will be a nice exercise. Take the wind turbine data, do your clustering, then use, if you're tall, you get some range, that is fine. On that cluster data only, you have the range. No, no, no clusters, no, fine, leave it. But at least try and see if failure or pass will happen.
That would be good.
Or you can give me build a logistic function and test. You can add to that now. you can add to that previous report saying, I built a logistic regressor for rotation, speed, and failing. Which model will work better? You can check.
I also did that where I got the failure values I got. Vibration level and failure in the heat map.
That is what, that is correlation matrix, no?
Yes.
So is there any value getting closer to 1 or -1?
No.
All are about 0 only,
About,
right?
yes.
Around 0
around
point,
0 itself.
and that means there is no correlation.
The highest correlation is what? 0.6.
0.6. 0.6 is something
No,
to
0.06.
ah,
0.06.
hardly anything at all, because it is cost 90 only.
And minus 0.06 and plus 0.06.
Right. Fine. Give me one. Somebody please build for price and C cylinder can be used. For mileage and C cylinder can be used. You will find out when you try to use price to predict the cylinder, what happens. When you try to see mileage and predict the cylinder, what happens? Using logistic, because one is metric, another one is class.
For plotting, we'll put it in loop. All these things.
It's up to you. Those fine tuning and all that is your choice. But I want the graph. I want some reports to be made. That when I used mileage to build predict the class, how is your accuracy? Because everything is there. Do you need to do any effort here? Nothing. Accuracy score, everything is ready. Just change the data. See, just change the data, and that's it. Your accuracy score you're getting, right?
Yes.
You can easily make a report of it, right? Later, for a company, if you're going to write a pipeline like this, you can build that report, add it to pandas table, and export it as Excel also for different iterations. You can write one pipeline which will be used forever for newer data that is coming up, like wind turbine data. Everyday data is getting generated. We need one pipeline. So the pipeline is fixed. That's what you use in your cloud deployment. That's what you do with tablet
When we
pipeline.
get into that company and
Yeah, that we can't teach, because then we'll have to teach 10 different tools. When the company, we don't know whether they are using data lake or whether they're using AWS, whether they are using GCP and hybrid. That is the company's problem. They will train you. Okay, ML ops and all that, they will train you. But you should be trainable at least. This they can't train. That is easy to train. That is 15-20 days of somebody from company will come and train. You do this here, do this here. But why you are doing this? This is a training. Correct? This is hard for them to train, because they will not take a bet on you. But once you show that you know all these things, then they'll take a bet on you. Correct? You understand? Correct? The difference. Fine. You guys go and do that and show me. Sir, okay, Ravi, I'll close this. And I hope